Good morning, student. We will start the new topic in a chapter number 6, work, energy and power. Last topic of this chapter, there is a collision. If two objects is in a motion in a straight line or in an angle, that means in a 2 dimension or a 1 dimension. If 1 dimension, two objects are collide with each other, then after the collision velocity become increase or decrease. Both the possibilities are there. So first of all we have to explain collision condition. Collision yani again and again two object is collide with each other in a 1 dimension or 2 dimension, right? So there is the possibility after the collision and before the collision velocity become different or same. There is the possibility. So first of all, collision has a two type. Collision has a two type. One is a elastic collision and the second is called inelastic collision, right? So two type is there, elastic collision and inelastic collision. Basic concept collision, after the collide two object and before the two collide object. First, collision is depend energy conservation law and it's also depend on momentum conservation law. Two condition, energy conservation law and momentum conservation law. But elastic and inelastic is a different part. Elastic collision, that means it also depends on momentum conservation law. But the most important thing, it's depend on kinetic energy conservation law. It depends on kinetic energy conservation law. So there is the important thing, kinetic energy conservation law, that means before the collision and after the collision kinetic energy is equal. Yani initial kinetic energy and final kinetic energy is equal. Okay, there is the elastic collision. After one, inelastic collision, that means again inelastic condition is also depend on momentum conservation law, but it's not depends on kinetic conservation law. That means initial and final is not equal. Listen properly, kinetic energy conservation law is not depend, but energy conservation is depend. That means this elastic condition, energy is converting potential to kinetic energy, possible potential to only mechanical energy, potential to internal energy. There is a different type is possible. That means always the energy is converting to another different energy, but it's not every time converting into kinetic to kinetic. So that's why there is the most important thing in elastic condition. Clear? So now we will explain about the next condition. Now the next condition is collision in a 1 dimension. Already I told you two condition is there, 1 dimension and 2 dimension. For one dimension has a two condition, inelastic, and then I will explain about the elastic condition. What is inelastic? It's depend on conservation law of momentum, but it is not depend on kinetic conservation law. So first of all start with theta 1 and theta 2 become 0. Yani simple thing there is in a one dimension. If it is one dimension, use conservation law of momentum. Suppose first object having mass m1 and its velocity is v1, and second object having mass m2 but it is in stationary form, yani v2 equal to 0. One type of the simple thing, if you are striking the ball in a billiard ball table and ball is moving in a straight direction and collide with this stationary another second ball. So the momentum conservation law, initial momentum is equal to final momentum. Initial yani m1 v1 plus m2 v2, they are equal to m1 v1 dash plus m2 v2 dash. But here you know that the velocity of second object is 0. So m1 v1 is equal to m1 v1 dash m2 v2 dash. So now what about the v2 dash? Okay, there is the base example. Now final condition is there, v1 dash plus v2 dash collide with them each other. Okay, so we will here the discuss, suppose one object is collide with the another object. If second object is in collide with first one, that means second is the same velocity, yani v1 dash equal to v2 dash equal to final. So and v1 is equal to initial. So m1 v initial is equal to m1 plus m2 v final. So that v final is equal to m1 by m1 plus m2 into initial. That is the equation number 1. Now after we have to use, if after the collision energy is lost, then delta K is equal to, no doubt we have to always write final minus initial, but here the kinetic energy is lost, so initial minus final. So the initial condition half m but v of I square and minus half, there is a m1 plus m2 and v of final square. So in the case of initial 1 upon 2 m1 v1 square minus half m1 plus m2 v of final square. Now value, put down the value v of f from the equation number 1. From equation number 1, delta K is equal to half m1 v I square minus half m1 plus m2 in bracket. There is the value m1 plus m2, m1 by m1 plus m2 whole square and then vi square. Now Here the m1 plus m2 whole square. So 1 m1 m2 is cancel. So left of the part is half m1 vi square minus half. Over here m1 square vi square by m1 plus m2. What is the common value? Half. Also m1 plus m2 become as it is, and m1 vi square is common. So 1 minus m1 by m1 plus m2. So again half m1 vi square LCM m1 plus m2 minus m1 by m1 plus m2. So m1 cancel. So half of m1 m2 by m1 plus m2 V of initial condition. There is a change in kinetic energy. That is the formula of change in kinetic energy. Now we have to find final energy. Okay, now collision in one dimension but elastic collision. Elastic collision, suppose initially case m1 object and its velocity is v1. Same in a straight direction, so theta 1 is equal to 0. So also we have to write down only magnitude form. The another object m2 but its velocity is 0. So first one is collide with the second. But which type of elastic collision? Elastic collision yani initial kinetic energy and final kinetic energy is same. So first of all, again there is a before collision, and now m1 is as it is but velocity is v1 dash, m2 is as it is but velocity is v2 dash, angle is 0. There is a after collision condition. Okay, so again use conservation law of momentum. What is conservation law of momentum? Initial momentum equal to final momentum. What about the initial momentum? There is a m1 v1 because v2 0 yani plus 0 equal to m1 v1 dash plus m2 v2 dash. Now suppose m1 is over here common, so v1 minus v1 dash equal to m2 v2 dash. Equation number 1. There is the using of conservation law of momentum. Now we have to use conservation law of kinetic energy. In elastic condition, no conservation in kinetic energy, so we have to find change in energy. But here we have kinetic conservation law of momentum, yani initial and final is same. So half m1 v1 square equal to half m1 v1 dash square half m2 v2 dash square. No doubt half cancel and m1 as it is. Now v1 square minus v1 dash square is equal to m2 v2 dash square. There is the equation number 2. Now division yani ratio, equation number 2 divided by 1. 2 divided by 1. So m1 is cancelled. v1 square minus v1 dash square upon v1 minus v1 dash is equal to m2 cancel, v2 square dash by v2 square dash. Now two part, v1 minus v1 dash, v1 plus v1 dash divided by v1 minus v1 dash is equal to 1, v2 is cancelled. So left of the part, these two portion is cancelled. So V1 plus V1 dash is equal to V2 dash, equation number 3. We have to find after the collision velocity in elastic condition. In a elastic condition, so start with equation number 3, multiply of equation 3 with M1, choice in your hand. If you are multiply M2, then go with them. But here M1 V1 plus M1 V1 dash, M1 V2 dash, both the side multiply M1 in equation 3. Now eliminate the equation of A with this. That means here already given M1 V1 plus 0 is equal to M1 V1 dash plus M2 V2 dash. Eliminate, so minus 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 minus, these two is cut. Left of the part is M1 V1 dash is equal to M1 V1 dash in a minus form, then plus M1 V2 dash minus M2 V2 dash. So if this M1 V1 is over here, then it's convert to M1 V1 dash is equal to M1 minus M2, there is a V2 dash. So now V2 dash equal to 2M1 V1 dash by M1 minus M2. There is the final velocity after the collision. Okay, now another option is there. Already we have to find V2 dash in a form of V1 dash. But second thing, also we have to find the V2 dash in a V1 form. But you should individual divide that theory. Okay, so also the another form, but student have ready to two theorem divide into part, but I have only one. So now again eliminate, but directly addition of this part. So 2M1 V1 plus M1 V1 dash is equal to M1 V1 dash plus M1 plus M2, because of M1 M2 is over here and V2 dash is common. Now this M1 V1 dash is cancelled. Before that part we have to cut V1. So there is the different condition is possible. One of them you have to explain. So here 2M1 V1 is equal to M1 plus M2 V2 dash, so that V2 dash equal to 2M1 V1 by M1 plus M2. Also you should take this value V2 dash, put down the value in equation A or B, yani 2 number equation, any of that, and you should find the form is V1 dash also. V1 dash is equal to, if you are find, then M1 minus M2 by M1 plus M2. M1 minus M2 by M1 plus M2 into V1. So there is the other condition for after the collision velocity. You should put this value V2 dash over here and calculate. But if you are not calculate, then you should write directly. So please student, be care this very important theorem. There is a collision in a one dimension of elastic condition. Before that we have to explain, in elastic condition. Now the next topic is two dimension elastic and non-elastic condition in the next lecture. So please read, write properly and learn that topic. We have explained the next example dependent on them. So be ready for that.